Hello, moving on to our next unit, we are going to start talking about arithmetic sequences. Now, these are new phrases that you may not have come across before, but this will be a common thing that you've probably covered in the past. You may not just have known what it was called. First, let's define what a sequence is. So a sequence is just a list of numbers. And it could be any old list of numbers. It doesn't have to be anything specific. So a sequence can just be any list of numbers. Now, a common difference is when you add or subtract the same number in a sequence. And for common difference, we're going to use the variable of lowercase d. So anytime you see d pop up, that means our common difference. Now, that brings us to the term of arithmetic sequences. And an arithmetic sequence, if you're trying to piece it together, we know that sequences are lists of numbers. So what is an arithmetic sequence? Specifically, it is a sequence that has a common difference. And I'm going to underline sequence was in pink, and then the common difference we did in this lighter blue. I forgot an E there. Oops. So an arithmetic sequence is a sequence that has a common difference. Now, using a lot of terms here, let's look at it with some actual numbers. So here's an example. Let's say I have the sequence 1, 4, 7, 10. Now, from this sequence, you may already have seen the pattern here, where notice from one number to the next, you're adding 3 each time. So in the sequence, you could actually start predicting what are the numbers that are going to follow after. So because you are adding 3 each time, your common difference, D, is a positive 3. And then we're also going to define different sub-numbers here. So what I mean by that is like A sub 1 is the first term. So this is first term. And in this sequence, A sub 1 is 1. I could also find A sub 2, and that would be 4. This is second term. So sometimes we may look for a specific term within that sequence. It will eventually build up to those. Here's another example, and this one I'm going to have some higher numbers here. So 51, 49, 47, 45, and I'm just going to add the 3 dots at the end. Now notice from one term to the next that you're actually subtracting 2. So your common difference here, D, is negative 2. Now notice that I put positive 3 for the first example and negative 2 for the second example. It is very important that you note whether it's positive or negative by saying that you're adding 3 or subtracting 2 here. Now let's also define a sub 1 is 51, and I'll do a sub 2 as well just for fun. That's 49. Now, why are we defining these things? What's the point and purpose of this? The point is to get to the explicit formula. Explicit formula. And I'll box this in a second. But the explicit formula is a sub n, there's a little n, it's almost like an exponent, but it goes down, is equal to a sub 1 plus d times n minus 1. Now, right now, this probably looks confusing, but let's define these different parts here. A sub 1, what this is this is the general nth term. So I could say, find me the 50th term in this sequence. So you might be able to piece together the formula and then say, okay, I could find this by doing blah, blah, blah. We'll get there. A sub 1, that's your first term. That's what we did over in our previous two examples where we found our first term, our second term, but here for the explicit formula, I only need that first term. D, we already defined that and saw it come up a few times. That's your common difference. And then finally, this n, this is the number of terms. Or number of term, rather, not number of terms. Just number of term. So that is the explicit formula. And I'm going to put a box around it here. But I'm going to actually make sure that the box fits. Okay, so using the explicit formula, let's look at an example of doing so. So let's write the explicit formula for the sequence of 3, 5, 7, 9. Now, when you're writing the explicit formula, here are the big things that you need. You need the first term, so a sub 1, and you need the common difference, d. So, the first term is in your list here. There's no math that you really have to do to figure that out. So, a sub 1 is 3. You could do that right away. With your common difference, you have to figure out from number to number, what are you doing each time? Notice that we're adding 2, adding 2, adding 2. So my common difference is a positive 2. Now, to find the explicit formula, I'm just going to plug these pieces in. This a sub 1, which was 3, and this positive 2 for d, I'm going to plug it into our formula of, and bear with me as I switch around colors, a sub n is equal to a sub 1 plus d times n minus 1. So notice there's only two things that you're plugging in. You're plugging in for a sub 1 and you're plugging in for d. Now if your d was negative, you could still do a plus and negative number, or you could change this positive, this addition sign, you could change that to subtraction. But we're doing an addition because our common difference was adding 2. So let's fill in. We got a sub n is equal to, our first term was 3. My common difference was 2. And then times n minus 1. So all I did was plug in a sub 1 and d. Now we can simplify this a little bit by distributing this 2 inside. So you get a sub n is equal to 3 plus 2n minus 2. And then you can combine like terms. You got a 2, or you got a 3 and a negative 2. So the explicit formula, is a sub n is equal to 2n plus 1. Now, we will go more in depth of how do you use the explicit formula and what it's used for, and even more understanding of it. But please copy down these notes into your notebooks, and we will start talking about this the next time that I see you in class. Have a wonderful day, folks.